is going, guys? Today we'll be talking about static methods of the math class. So we'll learn how to use static methods from the math class to implement numerical calculations in Java. So math can play a major role in our programs. It can become tedious to write out every equation we need in our code. Luckily, a lot of this work can be truncated using the math class. The Java math class is part of the java.lang package. It contains a variety of methods that can be used to perform numerical calculations in our programs. In this article, we'll discuss different types of math methods available to us and how to implement them in our Java programs. So rather in this video. And the math class also offers a good opportunity for us to learn about static methods. We'll take a look at how static methods are and how they're different from non-static methods. So first, we'll learn about calling static methods. So every method in the main class is static. This means that we can call and use these methods without creating an object of the class. There are two main options for calling a static method. Our first option is to append the dot operator to the class name followed by the method. So for example, you have math.min. So let's see it in action with the min method of the math class, which returns the smaller of two given numbers. So you can do math.min and not have to do anything else to basically do it. And how is this different from calling a non-static method? We don't need to create an object of the class in order to use the method it contains. Let's see an example of a non-static method. So for example, this is a non-static method. And essentially you would need a object to use this non-static method. So that's the difference between a static and a non-static method. And in our code above, we need to create a new object of type numbers in order to use the non-static method return sum. With non-static methods, if we don't create an object of the class or one of the subclasses, we don't have access to its methods. This isn't the case for static methods. And then our second option for calling a static method from the math class is to basically use this import statement. So import static java.lang.math and then .asterisk. So you can do either this way or you can use the math dot and then whatever method. So either one works. I would prefer, if you remember this statement, then just go ahead and write it once so you don't have to keep typing math dot blah blah blah, math dot blah blah blah. But if you think you'll forget this, then just write math dot blah blah blah, right? And here's some of the useful methods of the math class that can be implemented. So for example, we have the int abs, which basically it returns the absolute value of an int value. So I'm not going to read all this because let's face it, it's probably like trivial for most of you guys. So math.abs, it basically takes the absolute value of an int keyword int value, and 5 would return 5, -5 would also return 5. And then if you do have a question on how you can maybe make it accept double ones, there's also a double abs method as well. So it's the same thing except with doubles. So it's going to return the absolute value of a double variable. Okay, so there's a quiz right here, or like a mini quiz, yeah. So what will be the following statement output? Int x equals abs dot, or math dot abs -15 plus 5. So we know that -15 would become +15 plus 5 is 20, so 20. Got it. Yep. Then We have the double pow, which is basically the double base. So the base comes first and then the exponent. So this would print 125 because you have 5 to the 3, which is 125. So let's do a little practice problem with this. So what will be the following program output? So 2 to the 4 is 16. And remember, if we go back here, it's a double. It's a double. So it's not just going to print 16. It's going to print 16.0. Okay? So we also have the double square root, which basically it returns the double or the double of the square root. Returns the positive square root of a double value. So 49 squared is 7, so it'll print 7.0. Okay, let's see. Fill in the blank to create a program that outputs 9.0. Okay, so we have math dot square root. Perfect, because 81 square root 81 is 9. And we have the double random. Okay, so this is an important one. So let's go ahead and do this real quick. So the purpose is going to be it returns a double value greater than or equal to 0.0 and less than 1.0. So randomization is a great way to add probability to our programs. There are many ways to implement math.random in Java. Its default use case is to produce a random value between 0 and 1, essentially, or in double form. The random values can change every time we run our program. An example of the output is something like this. Okay, it's just random values. Now with some manipulation, we can actually use the math.random to create a random int or double value within a predefined range. For example, if we wanted, a random double between 0 and 10, not including 10, we would just simply multiply math.random by 10. So times 10, and you would get a random value, not including 10. Now, if we wanted a random int, we'd do the exact same thing, except now we would just cast it to an int. And then if we wanted our range to start at 1 and end at 10, we would do everything here, but we would also need a plus 1 because it would be from 0 to 9. So we shift it over 1 and then it becomes from 1 to 10, essentially. So now using addition also gives us the ability to start the range at any number. If we wanted an int value in the range of 10 up to and including 20, we would implement the algorithm right here. Now, I'm gonna honestly skip all of this because essentially what it's doing is the math.random. Okay, the math.random is very important. It basically, the addition shifts it, and then the multiplication. So the multiplication gives you how many numbers it wants, and then the addition shifts it. So we multiply it by 11 because our max value minus 10 is 11. And then we add plus 10 so that our smallest value is guaranteed to be 10. Okay, so here's another way to think about this algorithm. The value that you multiply determines the number of possible values you get. The number that you add defines the starting value. So times 3 plus 5, it's going to be starts at 5, and so it can give you either 5, 6, or 7. Basically like that. So we can run the following program to see the different kinds of random values we use to generate math.random. Okay. You have all of this. That's cool. Okay, now which of the option will produce an int with a range starting from 3 up to and including 8? So including 8. So including 8. So we would do 3 and including 8 would be how many numbers? So from 3 to, so it start at 3, so it'd be A, C, or D, and then you need from 3 to 8, so it's 6 numbers, so it should be this one. Yep. And then we have additional methods. Methods aren't the only methods. So we see a bunch of methods of the math class. So we have a question here. Which of the following is not a method of the math class? Hint, you might want to check the math class documentation. So let's do it without checking the documentation. So I believe tan H should be one. Round down should be one. Hypotenuse should be one. This one probably isn't. What? Huh. Okay, let's figure this out. Is it hypot? No, hypotenuse has tan H. Oh, round down. Okay, so for round down, I think it's math.floor. Okay, makes sense. Okay, great job reaching the end of this video. Let's recap. So the math class is part of the java.lang package and provides useful static methods for performing mathematical equations. To call these static methods, reference the class name and the dot operator plus the method name. To only reference the method name, use the math class. Import the math class into your program. For students taking the AP exam, several methods will also be available in the reference sheet. So that's going to basically end it. So this was the static methods of the math class. So I'll see you guys in the next one.